Hello student, welcome to our physics discussion, that is physics in a smart way. There has been a small gap in between our last video and today's because ensuing vacations and all that. Okay, so let us get on with the topic. We go to an issue which is usually branded as the topic's branded as degree of freedom. Degree of freedom. Usually the symbol I have taken, that is small f, that when somebody refers to degree of freedom, we may not write in lengthy words, we can write small. So when you come down to degree of freedom, and one has to understand in the context of thermodynamics, but let us first start our discussion on the broad level. That is an issue which can be taken up in many different topics. Let us say we got a pulley system, that is the first pulley system, that is the second pulley system I am showing you. In case of pulley system of movement of pulleys, usually we brand that topic under heading that is constrained motion and all that. So there we can use degree of freedom. So there degree of freedom means how many different independent type of motions you can think of, or you can perceive or are perceived. In case of figure 1, that is a pulley, there are two blocks. Of course, the diagram shows them the blocks to be at rest, they need not be. In this case, we can clearly see A and B, the blocks are connected by the rope which goes over the pulley. The pulley center is static, that is connected to the ceiling. And if A goes up, then we know that B must be coming down, or if B goes up, A must be coming down. The rope is connecting both the bodies and they cannot move independent of each other. So that is only one style of motion for the blocks, A and B. Either the pulley will be going up or coming down, but the pulley must be connected and they move. Okay. So thereby, degree of freedom for this pulley, usually we write that degree of freedom is equal to 1. For this pulley, degree of freedom is equal to 1 or F equal to 1. Let us go to the second diagram where the block A is connected via the pulley to the center of another pulley, which is not fixed to anybody. Second pulley has got two blocks, one is B and third is C. They are interconnected. In this case, yes, let us come back to the first case. In the first case, in the figure 1, we have already described that degree of freedom equal to 1 because if somebody gets hold of one body, if I hold on to A and stop its motion, the entire motion will be arrested. Similarly, if you check the motion of B, the whole motion will be arrested. So thereby that gives another indication that degree of freedom equal to 1. But in this case, we know if we grab hold of A, then A won't be, or this rope which connects the A and pulley won't be moving, but still then we can have B and C, intermotion between B and C. To stop completely the motion of the whole system, in addition to A or pulley, we have to hold one more body, B or C. Either you hold A and B, or you hold A and C at rest, or you may hold the pulley and C at rest, or pulley or the B at rest. So thereby, because we hold two bodies, and only when two bodies are restrained, then the motion of the whole system can be stopped. So thereby, degree of freedom for this will be equal to 2. Whereas in figure 1 or in the first pulley system, the degree of freedom was 1. Here degree of freedom equal to. Similarly, we can increase the degree of freedom in place of block B or block C. If you put another pulley and put two more blocks, we can easily imagine that you can increase the degree of freedom of the system. So similarly, degree of freedom will be usually in those contexts, it is usually seen in that way. Let us say, we may take a thing just like your door frame and door. Door frame and the door. Your door is usually hinged to the doorpost, and door can only rotate about the doorpost. So thereby your door has got a degree of freedom of only one. It can have rotation about the doorpost, about the that in my language I say it's kabja, that is the hinge or pivot or whatever it is. Yeah. So usually the door has got a degree of freedom equal to one, because door can have, is allowed to have only one motion, that is rotation about the pivot or about the doorpost. Doorpost and the door, they are hinged together. So that is the idea of the degree of freedom. Okay. But in case of our job is to not consider the degree of freedom of the police and all that, we are just starting to discuss the idea. Our job is to find the degree of freedom of gas molecules. Gas molecules. Whenever we think of gas molecule, we think of starting, or we think of imagining from the level of an atom or a molecule, or maybe a monoatomic. Let us say we got a point mass. We got a point mass. When you get a point mass, usually you can see a peculiarity here. I'll be using a method that is known as half truth. Half truth. Truth. Usually, if a thing is slightly difficult, the child is not fed the whole thing. The child is taken around a way where it is easier. So usually that process is known as a half truth. And gradually, when the mind matures, the child automatically knows that the way. And the deception, of course, the teacher that have the use. But teacher doesn't want to deceive the child, doesn't want to feed wrong or false thing to a child, but that is the way usually when the original or the thing is difficult, the teacher takes a easier course. That is the path of the habit. Let us say point mass. We are now discussing the degree of freedom of a point mass. Point mass. The point mass is a small one. If somebody here asks about degree of freedom, why you were interested of the degree of freedom of point mass, and what does the degree of freedom mean if you are talking of a point mass, then the answer can be that when we go for a scientific study of the point mass, what it can do, what it can, what it can perform and all that, we know, scientifically when you observe a point mass, we do not see the color of the point mass, not see how how good it is, how bad it is, okay, how rational it is or how irrational it is. Usually, whenever we discuss a mass in physics, we may be at least interested for its position, for its motion, for its momentum, or for its kinetic energy. If you are interested in the position of the mass, then you know the position of the mass is usually given by three quantities. Those are known as coordinates. One is x, other is y, third is z. Why three coordinates? You know the space can be divided into three independent directions. One is x-axis, other is y-axis, third is z-axis, and all the axes are independent of each other. They are perpendicular to each other. Okay. So if somebody tries to define the position of the point mass, then you know it can be done with the help of coordinates. So as you know, the position of the mass can be expressed scientifically with the help of three coordinates. One is x, the second is y, third is z. Similarly, if let us say the mass is having velocity, the velocity can also be broken down into three components. One is x component of the velocity, second is y component, and third is z component. Similarly, the momentum can be resolved into three components. One is x momentum, other is y momentum, third is z momentum, and the total momentum, if we say that is P, it can be expressed as the vector sum of its x momentum and y momentum. Sorry, that pen doesn't cooperate with me. Y momentum and z momentum. Okay. Similarly, position vector can be written as r equal to xi cap plus yj cap plus zk cap, as you know. Similarly, kinetic energy also can be written as if the kinetic energy of the mass is half mv square, then it can be written as half m vx square, that is x kinetic energy, plus half m vy square plus half m Ez square. Okay, here we have broken down kinetic energy into three coordinates. Okay, so thereby my purpose of elaborating this is to establish that a point of mass has got degree of freedom three. Usually when we elaborate that, we say point mass position can be expressed in terms of three coordinates. Its momentum, its kinetic energy, its position can be expressed in terms of three coordinates, all those things. So I think I am clear that degree of freedom for a point mass is 3. And that is valid for a monoatomic molecule, because monoatomic gas or a monoatomic molecule, we know is nothing other than a very small point mass. So for a monoatomic molecule, you start to remember that degree of freedom is equal to 3, and it can be explained, or it is usually expressed like this. Okay, when I put down like this, I'm using an idea that I told you that is half truth. We have to wait for some time. So let us wait for our next video where I will be elaborating the issue further. So thank you for your kind cooperation, and thank you for your essay.